Hey, this is Ken from Maker's Box, and we're going to show you how to put together a Tacuino kit today. And the first thing we always want to do is make sure we've got all our parts. So you can see our circuit board here. We've got two 22 ohm resistors, two 330 ohm resistors. We've got a 1.5K resistor, two signal diodes, and a power diode. And then we've got our light detector. Looks like a clear LED, and then we got our power indicating LED and our main LED. We've got a 4-pin right angle jumper, USB connector. We've got our chip, battery holder, 2 capacitor speaker, and switch. So nothing's worse than getting into the middle of a project and finding out you don't have everything you need. So when I'm doing these boards, I like to work from highest to lowest as far as board height. And so let's go ahead and start with resistors, are a good choice. So these are our two 330 ohm resistors. These are current limiting resistors for the LEDs. So we've got one that goes up here where the main LED is, and you can see on the silk screen it's marked 330. So you know that's the right one. And we'll get that snug in there. And then we've got one for the power. Let's save that one for later. Let's do 22 ohm resistors, part of the USB circuitry. And also go in there and there. Those are marked 22. And then above that is the 1.5K, which is the oddball out here, has a green band on it. So below our 22 ohm resistors, we're got our two signal diodes. Now these have a polarity. You can see on the silk screen there's a white band to show you, and then on the item itself there's a black band to show you the direction. So these have to go in the correct way or the circuit will not work. And so those black bands are going towards the USB circuitry, and I'll use my pliers to pull this flat. And then maybe the last thing we could do up here is our big diode, our 4001. And so it's got a polarity as well. It's got a silver band on it, and in this case a white band is pointing towards the speaker, so it's opposite of those two we just put in. Okay, that's quite a bit thicker leads. Okay, so we've got a good set of resistors to start working on here. So we'll flip it over, and I'm not going to make this a how to solder tutorial, but there's some of those on the web that do it a lot better than I can show you up here, but I'll just kind of talk through how. So you got your tip nice and clean. This is my $10 Spark Fun soldering iron, and I'm using lead-free solder. And touch the pad and the lead of the component for about 2 seconds, and then introduce just a little bit of solder, pull away, and you should see a really nice tint as it wicks in there. You always want to pull your solder away first, otherwise it'll get hung up in there and you have to come back and reheat it. Do that all the time. The diode's leads are a little bit thicker, so it takes a little more heat. But other than that, it's just like the resistors here. And moving on up the row here. This is kind of hard to do, watching the screen and the soldering at the same time, making sure you guys are seeing what I'm doing, but I think we'll make it. Okay, so once you have those in, I'm going to come in and cut those off as close to the board as possible, and I usually put my finger over the lead to keep it from flying out. When we're doing our soldering classes with kids, they're always wearing safety glasses, so don't want the solder to splatter in an eye, or more likely it's getting one of these leads flying out. These can go a long ways. Alright, that's looking a good start. So let's see, as far as height wise, let's go ahead and put in a number of things that are just right about the same height. So how about our piezo speaker here? So we'll either pull the tape off that or give it a clip here. And that goes up in this area here. It sits fairly flat. And well, alright, let's just do that real quick. Piezo speaker. So again, the order's kind of arbitrary. I just kind of do it so that when it's sitting on the ground, since I don't have a helping hand or a vise, I actually do, but I don't use it very often because it takes more time to set things up than it does. So speakers in place. We have our 0.1 microfarad capacitor. Now that goes up right near where the microprocessor is. This is for just smoothing the power out a little bit, keeping your microcontroller happy. And that type of ceramic capacitor doesn't have a polarity, whereas the other one we put in will. Okay, clip those off. Okay, let's put our battery holder in. So this has a notched opening. This is the side the battery will slide in, and we want that on the bottom of the board. If you put it in upside down, it's going to be hard to get a battery in with the speaker in place. Flip that over. And these are going to take a little more heat than usual because that back dissipates a lot of heat, but it's not too hard to get a good solder joint. And I'm just using my finger to hold it down. Okay, and let's go ahead and put in our microcontroller. This is probably the most critical piece. If you get this in backwards, they tend to overheat. There's a dot. I usually paint it after I load the firmware on. On the silk screen, there's a little indication of which way it goes, so it's pointing towards the battery. And take it out over its foam. You can see that sits right about the same level as the battery. And let's go ahead and just solder in some opposite corners here. So there's one and there's the other. So on a multi-lead component, I usually solder in just two and then come back and make sure that it's seated correctly, and we'll double check the orientation. It's far easier to get the chip out and switch it around at this point. Once you get more than 2 in, it gets real difficult. So I'll sign off on that one. Let's just go ahead and finish up the other. So I really like the ATtiny 85. It's got just about the same horsepower under the hood as the ATmega. It's just got fewer input-output pins and a few other differences, but for just about any project, it's good enough. We're going to do 2 inputs and 2 outputs, and that'll be just enough to knock out a really nice project with a $1 chip here. Okay, so while we're down here working on the MCU, so we're still about the same height here. I'm going to throw the switch in here, and that. And let's go ahead and throw in, this is the header that will be used to program the chip after the board is disassembled. So you can see it sits right up against the piezo speaker for now, but once we break these apart, then it will go into this section right here to reprogram the chip. So let's solder that in place. You know what? And I did not have that in there. It snuck away from it. Alright, well, maybe here's a chance where I can show you how to use solder wick. So this is a copper braid, and I'll just place it over there, apply some heat, and that you can, I don't know if it's going to come up on the video, but that silver sucks right out of there. And it actually cleared the hole. Alright, let's try this again. And this time, I'll show you a lot of times I like to use masking tape to just hold components in pieces. If this guy's going to be a problem, we'll tape him down and get him in there. Done with him. Guess you could leave that out and solder after you break it up if you want to. So we've got a few components left. Let's go ahead and put in, working back towards our power section here, we have an electrolytic capacitor. So its longer leg is positive, short leg's negative, and then on the case there's usually a negative mark. And so on our PCB board here, 10 microfarad, and there's a small plus sign, and then the plus pad is square. Has another little indication, so that'll go in like that. And we'll solder that in there. Okay, so we have a LED that will indicate when the power's coming from USB, so we're going to put a red LED in there, and like the capacitor, it's got a long leg which is positive and a short leg which is negative. And then if you look closely at the casing, there's a flat edge along the negative lead, and so if we look at our silk screen here, there's a positive and then there's a flat edge over here, so this is going to go right like that. And the color of the LEDs is pretty arbitrary. You can put what you want where you want it. I usually use red for power, Green works too, yellow works. Okay, so and this guy had a power limiting resistor. It was a 330, and it snuck off on me here. Where did that go? And so for you can see how it's together. The two pads are closer, so we're going to put it in a vertical arrangement here like that, and slide it in there. So the rest of this board's kind of engineered to be as flat as possible, but over here on this programmer side, we're not so worried about the height, as that programmer section is probably going to be removed if you're doing soft circuits. Okay, so let's okay, so we're down to just 3 components here. We've got our light detector. Let's put that in. So that goes up here where it says photo. It's connected to pin D5. It's got emitter, which is the longer leg, and the collector, which is the shorter leg. And so this is kind of opposite of how I think of LEDs, with the collector being the positive, and it's actually the shorter leg on this. So on the silk screen you can see a longer and a shorter leg on there. I'm trying to make it as easy as possible, so you don't have to look it up every time you go to solder one of these guys. Kind of like my boards to be self-documenting. It's not always the case. Okay. I used to use cadmium sulfide photoshells, but they're getting a little expensive, and they have hazardous materials in them. These photo transistors actually operate in order of magnitude faster as far as detection time. So the only issue is you got to get them in the correct orientation. That just leaves our main LED. In this case, I'm going to make it blue. Long legs positive. Positives on the silk screen here, and negative. So again, the color is kind of arbitrary. If you have an idea for soft circuits, or you want to try and bend this off to the side or something, go ahead and do it up. You can think a million ways you can do this. In this case, we're just going to solder it to the board. Seem to be getting sloppier the farther we go here. Need to almost done. Okay, that leaves the final component is the USB connector. This comes down here, so it's got 2 mechanical connectors and then 4 actual electrical connectors. So we're feeding those through, trying to get them all through at the same time. And that works great, so it overhangs the board a little bit. And the bigger ones we are going to solder in place. They're mechanical. They take a little bit of heat and a lot of solder, but this gets a lot of stress as you're plugging things in and out, so we want it nice and tight, and that protects these finer leads from mechanical stress. Okay, so just wanted to finish up, do a final check, kind of look around, see we got everything we like. So this one looks like a cold joint. It's not quite tinted the way I like. Make sure we got all our connectors and no bridges, no missing solder. Looks good. So the firmware, if you buy the kits from me, will come pre-programmed with something on here, so you should be able to We'll put the switch in the off position. We'll put in our coin cell. The micronucleus bootloader takes 5 seconds, so from turning it on, we gotta wait 5 seconds. 1,000, 2,000, 3,000, 4,000. And I saw a blank on there, a double blank. So now, if I touch it, you should see a heartbeat. Touch it again, it goes off. Hopefully that's showing up in the camera. And then if you turn it off, and I will touch the pad. So this is to get it to the sound mode, and so I'll turn it on and get to hold it for 5 seconds. So you see the blink here. So 3 blanks, so now there you go. Ready to embed it in a project or program it. So thanks for watching. This was Ken.